Hey everybody, this is Larry. This is me doing week 4 of the Premium Leetcode challenge. Apparently I've done it before, so we'll see how that goes. We'll do an extra problem after this, just a random one I haven't done before. 1167, minimum cost to connect sticks. You have some number of sticks with positive integer lengths. These lengths are given as an array sticks where sticks of I is the length of the ith stick. You connect any stick and then you could, okay, minimum cost. All right, I mean, okay. So basically, I mean, this is gonna be greedy. I'm trying to figure out which way to do greedy. The idea is that I mean, I think I know. I'm trying to figure out the way to justify it. I kind of in a way after you merge a stick, the idea is that previous sticks are kind of reused as many times as needed, right? And you're trying to like minimize that cost function. And I think the greedy way is just to take two of this shortest stick you can do every time and then just keep on combining them and until you have one stick. The reason why is probably, I mean, the thing that I always say is that comes up very often is exchange argument. Because, okay, let's say, okay, let me do the proof real quick. I mean, I think the code is pretty quick and easy. Once you understand what's going on. But let's say you have x, y, and z, right? And then you have x is less than y, less than z. And then here, you really have three ways of, well, there, maybe, no, yeah, the three ways of doing it, right? 3 choose 2. Is 3 choose 2, 3? I think so. Maybe not. Well, how many other ways we can enumerate this, right? The idea is that, okay, let's say we chose x plus y for the first one, and then the second one is going to be this again plus z, right? So you have these things to choose from, and of course you can also do x plus z, and then y plus z plus x, right? So these are the 3 ways that you can do it. And as I said, that's just like the combination of 2, and then you have to do it again with the stick that you added, and then add the last thing. So these are the things, right? I'm a little bit lazy today, so I'm not going to go in detail, but suffice to say that it should be clear that this one is the minimal, right? I mean, because z is bigger than y, and in this case, that means that you have 2 times it. So, so if you subtract these two, right? For example, yeah, if you subtract these two, for example, the top 2, and you can generalize it to the bottom a little bit if you went on your free time. I'm a little bit lazy, but yeah, ASCII art is hard, right? I'll just put this in the bottom, right? So let's say you subtract these 2 things, and it should be clear that, right? And you can kind of rewrite this as 2x plus 2y plus z, and this is 2x plus 2z plus y, and of course the x's cancel out. So then now you have z or y minus z, right? And of course, given that this is the case, that y is less than z, this is going to be a negative number, and this is a negative number, which just means that this number is bigger than this number, so we should always choose this one. That's basically the idea, right? And you could I mean, we don't have 3 things, but you could use induction to kind of add in more numbers and kind of like figure out which one to use, right? So that's basically the idea, and maybe you have a few more cases with Leetcode 2 or something like that, but that is the idea about the proof, and that should be good enough for us to kind of do stuff with. We can do something like heap_heapify sticks, which in Python it is a min heap. So while and I know that I'm being a little bit lazy today, and I'm kind of using this in place, but you should, okay, fine. Let's just, right? I don't know that actually, does that work? I think this works now. So okay, let's just do that, right? So then now this is just A is you go to heapq.heap_hip_pop s. B is you go to heapq.heap_pop also s. And then you and then you have like the total cost is equal to 0 for now, and then total we add A plus B, heapq.heap_push A plus B back into the heap, and we're good, right? And then when we have one item, then that's it, right? So yeah, oh, oops, I forgot to put in S. I always forget to do it because it's such an awkward syntax. Usually you would have a priority queue or heap object, and then you kind of do operation on it. So I always forget it as part of the parameter. It's very awkward. But in any case, yeah, what's the complexity here, right? This is linear, and this time for every iteration, this gets one fewer. So that means that this will happen all of n times. I think it's n minus 1 times to be precise, but all of n times. We have 2 pops, 1 push. So that's going to be log n, log n, log n. So n log n. Yeah, that's all I have for this one. Let me know what you think. Pretty straightforward, I hope. The proof is a little bit tricky if you haven't done it before. Hopefully this kind of sparks you. And that's all I have for this one. So yeah, stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.